Hello everyone, welcome to the online class of this ISC Physics. So today we are going to start with the new chapter of ray optics, and that I have already introduced in the last class also. And this chapter name is called Refraction of Light at a what surface? Plane surface. Now this is one of the important chapter that even you have learned in class 10. Now the same chapter we are going to learn even in class 12, but in more details. Now, to tell you about the light, light has many nature and the properties. So to tell you about the properties of light, light can be reflected, and that we have already learned in the previous chapter, that is for spherical mirror. Light can be refracted. Now there will be another property that is called light can be diffracted, light can be interfered, and light can be polarized. So I am telling you these terms as the property of light. But let me tell you, light has a nature also. Now, nature of light is basically considered as a wave nature. That you learn in details in the wave optics. Now, taking the consideration of ray optics, now you know that when light travels in a medium, now basically light travel in a what line? Straight line. Means when we talk about the traveling of light rays, definitely light travels with a certain speed. So when we take a medium, particular medium, the speed of light in a particular medium remain constant. But what happens when the light passes from one medium to another medium? Now definitely the path of the light will change, or there will be a bending of the light takes place from one medium to another medium. Now this particular bending of the light rays is considered with the property, or I can also call as phenomenon, and this phenomenon is basically known as refraction of light. So my dear students, so we start with the refraction of light. So in this chapter, we are basically going to start with the introduction. Then after we follow the Snell's law and the concept of refractive index. Now to tell you about the refraction. Now for refraction of light, we must require two medium. But this medium must be a medium having what density? Optical density. Now to introduce with the topic called optical density, let me just start by taking one of the mediums, say air. Now let me taking another medium, say water. Now when we consider medium like air and water, basically light travel with different speed in air and water. So any medium in which the light travel with more speed is usually called as optically rarer medium. Now any medium in which the light travel with slower speed, that means if the speed of light decreases, then that medium is called optically denser medium. So when we take refraction light, there are two medium. One is called rarer medium, one is called what medium? Denser medium. But before I go to the rarer and denser medium and the light refraction through one medium to another medium, let me just show you the definition of refraction of light. The simple definition of refraction of light says that the bending of the light rays or change in the direction of the path of light when it passes from one transparent medium to another transparent medium. And this phenomenon, or this property I can also call, is also called as refraction of light. So this is a simple statement of refraction of light. And you can find so many applications of refraction of light in our day-to-day life. But the main part that we are going to do in this particular part is the refraction takes place from rarer medium, optically rarer medium, to optically denser medium, or from optically denser medium to optically rarer medium. Now let me take the case, like there are two medium, but any two medium are separated by a boundary, and this boundary is also known as interface. So this line I have drawn is simply called as boundary or interface. This is boundary or interface. So this boundary or interface separate two medium. So let me just take, for example, this is medium 1. And let me take for this example as medium 2. But remember this medium is an medium having optical density. So let me just take, if this medium is a rarer medium, then this medium will be a denser medium. So I have just classified for medium as rarer medium and denser medium. So what happens if light passes from in one particular medium, they basically travel in a straight line with a constant speed. But when the light enters in another medium, then definitely the path of light will change, That means there will be a bending of light takes place. And this bending of the light is actually defined by the phenomenon known as refraction of light. So for your understanding, so let me just take the example like rarer medium. So let me take the rare medium, say as air. So air is considered as optically rarer medium. Now I take another medium, say as water. Now I take water as an optically denser medium. Why? Because if you compare air and water, air is basically a gas, water is a liquid. So as for the optical density is concerned, the air is usually called as optically rarer medium. Why? Because the light travels with more speed in air. And if you take water, water is considered as optically denser medium. Why? Because the light travels with less speed in water compared to air. So taking this two medium, let me just take the case like light traveling from air to water. So there will be a source of light. Let me take this as a source of light. So what happened to the ray of light? If travel from a source, as for the ray optics, it travel in a what line? Straight line. So let me take this ray as a what ray? Incident ray. So when light incident at a particular point on the interface, this point is called the point of incidence. Now when light incident at this point, definitely the medium changes, so that what happens? The speed of light changes. So usually what happens? The light path will change. So as for the consideration, medium, when a light passes from rarer medium to denser medium, the light usually bend towards the normal. Now the reason why light bend towards the normal, that also I explain it afterwards. Now for that, let me draw a line, a perpendicular line to the surface. Now you know this line is called normal. So what happened to the ray of light? As for the light passes from air to water, it bends towards the normal. So this ray is basically known as refracted ray. So everyone knows this. This is refracted ray, and this is what ray we call? Incident ray. But in actual practice, let me tell you the fact that when light enters from one medium to another medium, the light never refract or transmit by 100%. That means there will be some partial refraction takes place in the medium. So for that also I consider this ray that will reflect back in the same medium is called refracted ray. Now let me tell you, this reflection, the amount of reflection takes place in the medium is basically less compared to the amount of refraction takes place in another medium. That's why in actual case when we take the ray diagram, so we neglect this reflected ray. So there is an angle which is made by this incident ray, and this angle is marked by letter I, as you know it. This is angle of incidence, and there is an angle made by the refracted ray with the normal, and this angle is called angle of refraction. We mark by letter what? R. So these two angles say that how much light can able to bend when it passes from one medium to another medium. So this is the diagram that shows that when light passes from rarer medium to denser medium, usually light bends towards the normal. Now I take another case where the light can even pass from denser to rarer medium. So that case also I can show in the diagram. Let me take this is medium 2. And that medium is a denser medium. And let me take this as medium 1. And that medium is a what medium? Rarer medium. Now, let me just take the opposite case. The denser medium I take as water, and rarer medium I take as what? Air. That means this time I take the case where the light passes from water to air. That means from optically denser medium to optically rarer medium. So usually what happens if light passes from a given source, from denser medium to rare medium, I can again draw that line, and this ray is known as incident ray. So when light incident at the point, this point basically known as point of incident. So what happened? The medium changes. So that's why what happened? There is a line I can draw. This line is called what line? Normal line. So this time when the light passes through the medium and it goes from denser to rare medium, this time the light usually change the path, but how it goes? It bends away from the normal. That means it goes somewhere in this direction. But in this case also I take that the light even reflect, but this reflection is a partial reflection. That means the light never pass through any other medium by 100%. So this is the partial reflection. So this angle which is made by the incident ray with the normal is called angle of incident, and there is an angle made by the refracted ray with the normal is called angle of refraction. Now for your understanding, we know the symbol I is the angle of incident. Symbol R we use as the angle of refraction. And this ray is known as refracted ray. This is refracted ray, and this is what ray we call incident ray. This is incident ray, and this is a reflected ray. And this line is known as normal. So if you look at these two cases where the refraction of light is concerned, we can clearly see that in one case the light is bending toward the normal, and in one case the light is bending away from the normal. Now, basically this bending of any light rays which pass from one medium to another medium is basically concerned or determined by one of the important terms that is we can define also and we learn in the law also, and this term is known as refractive index. Now, the refractive index is a relative property of two medium and is a measure of the bending ability of the light rays when it passes from one medium to another medium. That means refractive index value only determine whether by how much amount the light bends in a particular medium when it passes from another medium. Now for this measurement of refractive index, we basically follow a law, and that is a very important law which was formulated by Wilbert Snell, and this law is also known as Snell's law. So now we focus on what law? Snell's law. Okay, now we move to the Snell's law, but before I go to the Snell's law, let me even tell you that refractive index is measured in terms of the speed of light. And let me tell you, when we measure the refractive index in terms of the ratio of the speed of light, this particular part you even learn in more details in wave optics. And that was even verified by one of the great scientists known as Christian Huygens. And you learn in that particular topic. But let me just write refractive index. As for the statement, refractive index is basically symbolized by letter mu. So this is a Greek letter mu, but you can use a symbol like n. This is mu, and this is n, a simple letter n. But this is a Greek letter that we can use to symbolize refractive index. Now, as for the statement and the measurement which you do for refractive index, okay, let me write the symbol n only, is the ratio of the speed of light in medium 1 to the speed of light in medium 2. Now, medium 1 can be any medium. Like it can be rarer medium, it can be denser medium. Suppose if the light passes from rarer to denser medium, then this refractive index measure by the ratio of the speed of light in rarer medium to the speed of light in what medium? Denser medium. So this relation actually measure the amount of refractive index. But let me tell you, refractive index is a pure number and has no unit. But the value of refractive index plays a very important role, especially to measure how much amount of light that can bend when it passes through a particular medium. Now, taking this into consideration, Wilbert Snell even formulated a very important law that is called laws of refraction. But these laws is basically are two laws that you know very well. So let me just tell you what are the two laws of refraction of light. The first law, as you know, the first law says that the incident ray, the refracted ray, and the normal at the point of incident all lie in the which plane? Same plane. So for this particular part, let me show again you the diagram that the light passes from rarer medium to denser medium. Okay, so let me just show you with the help of diagram. Suppose this is medium 1, and this is rarer medium, and this is medium 2, this is denser medium. That means light passing from optically rarer medium to optically denser medium with this incident ray and refracted ray, and this angle is called angle of incident and angle of what? Refraction. Now taking this into consideration, you can simply understand the laws of refraction as the incident ray, the refracted ray, and the normal at the point of incident all lie in the which plane? Same plane. So this is a plane. So this blackboard is a plane. So all these rays, even the normal, lies in the which plane? Same plane. But the most important law in laws of refraction is the second law, we also known as Snell's law. Now Snell's law basically measure the amount of refractive index of one medium with respect to the another medium. So for that also we can see with the help of diagram also. As you know, the light passing from medium 1 to medium 2. So when light passes from medium 1 to medium 2, Snell's law measure the refractive index of medium 2 with respect to medium 1. So Snell's law simply say that for a given pair of media, medium is more than one medium, and for a light of given colors, and color of light is also determined by the wavelength of light. So please remember that color of light is determined by the wavelength of light. So for a given pair of media and for a given color of light, the ratio of the sign of angle of incidence to the sign of angle of refraction is always a constant. And this constant is nothing but refractive index of the one medium with respect to another medium. So just following the mathematical relation of Snell's law, that is also known as the second law of refraction. So I can simply write as refractive index of 2 with respect to 1 by sin I by sin R. So I am writing simply the relation of the Snell's law, which is a constant. Now, let me just tell you, refractive index, as you know, is symbolized by letter mu, and it can symbolize by letter n. But out here I am just showing you the symbol n. So I follow with symbol n. But it's not necessary you have to follow with symbol n. You can use the symbol mu also. So this case shows that when light passes from medium 1 to medium 2, it measures the refractive index of medium 2 with respect to medium 1. So it measures refractive index of medium 2 with respect to medium 1. So how it measures? Look at it. Refractive index of 2 with respect to 1 is given by sin I by sin R. That means the ratio of the sign of angle of incident to the sign of angle of refraction is always a constant. That measures the refractive index of medium 2 with respect to medium 1. So this was formulated by Wilbert Snellus. But I am telling you, this relation give you a lot of information, especially for the light, which bending of light is concerned. Now, in this particular relation, if you see, the most important part that you must keep in mind that when light passes from medium 1 to medium 2, it measures the refractive index of medium 2 with respect to medium 1. But if the light passes from medium 2 and medium 1, like we have discussed already in the previous case, then it measures the refractive index of medium 1 with respect to medium 2. So I can say that refractive index is one of the relative property of two medium, which can always determine the amount of light which can bend in a particular medium when it passes from another medium. Now, taking the case like we have taken rarer medium and denser medium. So if I take rarer medium is air and or vacuum, or denser medium is say water. So in that case also I can write refractive index of water with respect to air as sin I by what? Sin R is also a what? Constant. So just take the case. Rarer medium, if I take as air, this is air or vacuum, and if I take water as a denser medium, then it measures the refractive index of water with respect to air and given by sin I by sin R, which is a what? Constant. So this relation measures the refractive index of water with respect to air. Now let me just make you clear. If I take with air and water, water acts as denser medium. Air acts as what medium? Rarer medium. But not necessary that water can always act as denser medium. Water can also act as a rarer medium. If I take water and glass, because between water and glass is a denser medium, optical denser medium. Because when light travel in glass, light travel at slow speed as compared to the light travel in what? Water. So you have to keep in mind that one medium always cannot be called as a rarer medium or denser medium. So this is a Snell's law that can even help you to measure the refractive index. But I have already done that refractive index is measured simply by the ratio of the speed of light in medium 1 to the speed of light in medium 2. So if I follow this particular statement, refractive index of any one medium with respect to another medium can be calculated. So for that, let me just take the case. Suppose if the light passes from, okay, let me take the case of air and water. If the light passes from air to water, it measures the refractive index of water with respect to air. So in terms of speed of light, it can be written as the speed of what? Light in air, or also called vacuum, to the speed of light in water. Speed of light in water. Okay, now if you see this one, medium 1 is taken as air. All right. Medium 2 is taken as water. That is a denser medium. So if I follow this statement even also, refractive index of water with respect to air is measured as speed of light in air or vacuum to the speed of light in what? Water. Now this particular statement or relation of refractive index of water with respect to air is also known as absolute refractive index. So I'm using the term absolute refractive index. This is called absolute refractive index. Now that means when we use the word absolute refractive index, when we measure the refractive index of any medium with respect to air. That's why we measure absolute refractive index of water with respect to air as speed of light in air or vacuum to the speed of light in what? Water. Now from this particular relation, I'll give you some important consideration of the physical phenomenon that is related to the refraction of light. Now we start with the physical importance of the refractive index. Now refractive index give you especially the information regarding how much light can able to bend in a medium, whether it bend towards the normal or bend away from the what? Normal. So for that also I can show you with the help of diagram. I take the same case, like one case that the light passes from rarer to denser medium, where the light bends towards the normal. Say this is medium 1 and this is medium 2. As you know, this is angle of incident, this angle of what? Refraction. Now we can see that the light is bending towards the normal. Now if you look at this diagram also, from here also I can show that the bending of light takes place when light passes from one medium to another medium. So in terms of refractive index of 2 with respect to 1 is given by the speed of light in medium 1 to the speed of light in medium 2. So let me just take that speed as B1 in medium 1 and B2 as medium 2. So I'm writing in terms of B1 and B2. These are nothing but the speed of light in medium 1 to the speed of light in medium 2. Now, usually what happens? When light bends towards the normal, it bends towards the normal due to the what? Decrease in the speed of light. That means when light passes from medium 1 to medium 2, the speed of light decreases. So one of the most important cause for refraction of light is the change in the speed of light. Due to change in the speed of light or due to the difference in the speed of light in different medium, the light usually changes the path. It bends towards the normal or bends away from the normal. But let me tell you, speed, when the speed of light changes, another factor also changes. That is wavelength of light. When the wavelength of light changes, there is another factor that can even change, that is called intensity of light. The intensity of light means the amount of brightness of light. But the only factor that does not change when light passes from one medium to another medium is the frequency of light. So remember this, frequency of light always remains constant when it passes from one medium to another medium. So this relation, if you see, in this relation, B1 is greater than B2. That means when light passes from medium 1 to medium 2, that means this is rarer medium and this is what medium? Denser medium. The speed of light in rarer medium is always more than speed of light in which medium? Denser medium. So if B1 is greater than B2, then refractive index of 2 with respect to 1 is always greater than 1. See, refractive index of 2 with respect to 1 is always greater than 1. So let me take the case like if light passes from air to water, refractive index of water with respect to air is always greater than 1. Now, but if the light happens to pass from medium 2, medium 1, let me write this medium 1 and medium 2. And if medium 1 is a what medium? Denser medium. And medium 2 is a what medium? Rarer medium. As you know, the diagram says that if light passes from medium 2, denser medium to rare medium, light bends away from the normal. So in that case, what happened as per the Snell's law, for the statement of refractive index of 2 with respect to 1 is given by even by B1 by B2. But in this case, what happened? When light passes from medium 2 to medium 1, then the speed of light in medium 1 will be less than the speed of light in medium 2. That means when light passes from denser medium to rare medium, speed of light in medium 1, denser medium, is less than the speed of light in medium 2. So if this numerator becomes smaller than denominator, then refractive index of medium 2 with respect to 1 will be less than 1. That means refractive index of 2 with respect to 1 can be greater than 1 if light passes from rarer medium to denser medium. If refractive index of 2 with respect to 1 will be less than 1 if light passes from denser medium to rarer medium. So this value of refractive index can even determine whether the light bends towards the normal and away from the normal. So again, let me add, in this particular diagram, is bending towards the normal. So if light bends towards the normal, definitely I will be greater than what? R. See, I will be greater than R. In this case, this is I, this is R, but in this case, I will be less than what? R. That means when light bends towards the normal, angle of incidence is greater than angle of refraction. When light passes from denser medium to rare medium, angle of incidence is less than angle of what? Refraction. So these are the concept that is basically light in the refraction of light. But let me tell you, the value of refractive index determined by how much amount the light bends in a particular medium when it passes from another medium. So again, let me show you the relation, like the relation of water, refractive index of water with respect to air. We have already done it. Is nothing but the speed of light in air to the speed of light in water. Light in water. So if you look at this relation, refractive index of water is dependent upon the speed of light in water. That means refractive index of any medium. So I am taking as water, but not necessarily it can be a water. It can be any denser medium with respect to rarer medium. So this is simply written by as C by B. So please see the diagram. Speed of light in air is basically symbolized by a small letter C. Speed of light in any medium other than air is symbolized by a small b. So this relation says that if the speed of light in any medium decreases, refractive index increases. That means if b decreases, refractive index of a medium increases. In that medium, with respect to air, increases. But remember, this is I'm done with the water, but this relation is true with any denser medium with respect to rarer medium. That's why one of the densest medium is diamond. That's why the refractive index of diamond is maximum, almost 2.4. Why? Because the speed of light in diamond is least. That means any medium whose refractive index is maximum more than the speed of light is what? Less. So refractive index and speed of light in that particular medium are inversely proportional to each other. So this is the concept behind the refractive index. Okay, now as you know that due to different speed in different medium, the light usually change the path. Now this is the reason that's why the light usually bent either towards the normal or away from the normal. Now I've already discussed the refractive index, but the only medium you know that where the light travel with maximum speed is air. Other than air or vacuum, the light travel with speed less than air. And you know what is the speed of light in air or vacuum? Is 3 into 10 power 8 meter per second. So if light passes in water, the speed of light in water is say 2.25 into 10 power 8 meter per second. If light passes in glass, then the light travel with a speed of 2 into 10 power 8 meter per second. That means other than air or vacuum, light travel with the speed less than the air. Okay, so this is the concept that is required. Now the next topic that we are going to discuss is the reversibility of light. The next part is what? Reversibility of light. Now reversibility of light simply say that when light passes, the path of light is reversible. That means when light passes from one medium to another medium, the same light can return back in the same direction to the initial medium. And this phenomenon is called reversibility of light. But before I go to the reversible light, I just want to do one special case in the refraction light which takes place. As you know, the light travel in a medium in any of the direction. But suppose if the light falls normally in a medium, any medium, say medium 1 to medium what? 2. And medium 1 can be a what medium? Rarer medium. It can be a denser medium. Or it can be denser medium, it can be a rare medium. So when the light incident normally, means when light incident normally, what happened to the layer of light? The light goes straight. It means it goes undeviated. So this is a special case in which the light can pass through another medium with a different speed, but the light will not change the path. So the reason behind this can be understood with the help of Snell's law. So we know Snell's law, refractive index of medium 2 with respect to 1 is given by sin I by sin R. if you look at this particular relation, when the light incident normally, angle of incident becomes 0 degree. That means the incident ray and the normal exactly coincide to each other. So if light incident normally, that angle of incident is 0 degree, then we can calculate the value of angle of refraction from this relation. So what we can do for this? I can make sin r as the subject. So if I make sin r as the subject, it will be sin I by refracting index of 2 with respect to 1. So look at this relation. I, how much? 0 degree. So it will be sin r equals to sin 0 degree by refracting index 2 with respect to 1. And you know sin 0 degree value is 0. That means 0 divided by any number is even what? 0. So sin r is 0. If sin r is 0, that means definitely r is also 0. Because sin 0 degree means 0, which means sin, that means r is also 0 degree. That means the angle of refraction is also 0 degree. So this is the case where the light does not deviate from its original path. It goes undeviated. But in this particular case, what happened? The speed of light changes, but without changing the direction of light. So this is one of the important case for the refraction of light is concerned. Now, I go to the part that is called reversibility of light. Okay, now we go to the phenomenon or the term that related to refraction of light that's called reversible light. Now, this reversible light say that the path of light is reversible. But this phenomenon does not say that the path of light is reversible, but it makes a very important relation to derive a relation of refractive indices of any two medium. So let me come to that part. Okay, let me just take the case of one medium, say medium 1 and medium 2. So again I remind you, medium 1 can be any medium, medium 2 can be any medium. So I consider medium 1 as a what medium? Rarer medium. And medium 2 as a what medium? Denser medium. As you know what happened when the light passes from rarer medium to denser medium, the light usually bends towards the normal. So again, I follow the diagram of the light bending of the light takes place from passing from light rarer medium to denser medium with I and what? R. This is incident ray. This is what ray? Refracted ray. But I have to make the path of light to be reversible, to return back to the same direction. So what I do, I just keep one of the mirror. And this mirror is called what mirror? Plane mirror. So I'm keeping one plane mirror. So what happened? This is the incident ray, this is the refracted ray. But once the light incident on the plane mirror, it incident in such a manner so that light incident normally on the plane mirror. So in this case, the light reflect. That means it can return back in the same direction. So this becomes the incident ray for the light passing from medium 2 to medium 1. So let me repeat again. When light passes from medium 1 to medium 2, after refraction, it goes and strikes to the plane mirror. But this refracted ray becomes the incident ray for the plane mirror. So if incident normally, the light reflect in the same direction. Then this becomes the reflected ray. But remember this reflected ray becomes the incident ray for the light passing from medium 2 to medium 1. So what happened? When, without changing any medium, the light incident by the same angle, where the light refracted by the same angle. So this becomes the incident ray. Then light reflect and pass from this direction as the what ray? Refracted ray. So that means if the light passes from this direction, it returns back to the same direction. This phenomenon basically defined as reversibility of light. That is principle of reversibility of light. But I'm going to apply the very important law known as Snell's law to express a relation of refractive indices. So let me do that part. Snell's law. Just let me apply Snell's law. For the light passing from medium 1 to medium 2, how can I write? It measures the refracting index of 2 with respect to 1 given by sin I by sin R. Yes. That means angle of incident and angle of refraction. Okay, let me just keep this as equation 1. But the light, you can see in the diagram, returning back from medium 2 to medium 1. So if the light return back from medium 2 to medium 1, you can measure the refractive index of medium 1 with respect to medium 2. That means N 1, 2. So look at it, how to read this one. Refractive index of medium 1 with respect to medium 2 is given by sin R by sin I. So again, I'll explain it. Why this is sin R? Because when light return back from medium 2 to medium 1, this angle acts as angle of incident. And this angle acts as angle of refraction, according to Snell's law. So this is, using Snell's law, we got two equations. So what I do, I multiply these two equations both sides. Okay, let me just multiply equation 1 and 2 both sides, multiplying equation 1 and 2 both sides. If I multiply equation 1 into both sides, you can write refractive index of 2, 1 into refractive index of 1, 2 is equals to sin I by sin R into sin R by sin I. Yes, you can see in the diagram now, on the right hand side, sin R and sin R cancel out, even sin I by sin I cancel out. So it's coming as refractive index 2 with respect to 1 into refractive index of 1 with respect to 2 equals to 1. Yes, these are the refractive index of 2 with respect to 1 and 1 with respect to 2, equivalent to 1. But I can make any one as the subject. Okay, let me make refractive index of 2 with respect to 1 as a subject. Is equals to 1 by refractive index of 1 with respect to 2. Now look at the relation that I have derived. That is, if I take any two medium, refractive index of 2 with respect to 1 is just the reciprocal. This is reciprocal of refractive index of 1 with respect to 2. But this relation I can take with any of the mediums. Say, suppose medium 1 is air. And if I take this medium 2 is denser medium, that is water. So how can I write this relation now? In case of air and water, refractive index of water with respect to air is equals to 1 by refractive index of air with respect to water. So just see the diagram. 2 I replaced by water. So instead of water I wrote W. 1 I replaced by air. So instead of air I wrote A equals to 1 by refractive index of air with respect to water. So a principal reversibility of light clearly said that when the path of light is reversible, we can simply determine the refractive index of one with respect to another. So that means two refractive index of mediums, two mediums are simply reciprocal to each other. Now this particular principle is even very, very important in the next topic that I want to introduce, that is the refraction of light through parallel multiple medium. That means this particular case we take more than two medium. So more than two medium means say three medium, like say air, water and what? Glass. Okay, today I just want to do the introductory part of that refraction of light through parallel multiple media so that I can continue in the next class. Just showing that if there are more than two medium, say I'm drawing a line, this line is an interface or boundary, and taking this one of the medium as medium 1 and another medium as medium what? 2. Then I take another medium, that is what? A third medium, and that is medium 3. That means you can see there are two interfaces, one with medium 1 and medium 2, another with medium 2 and medium 3. This is medium 2 and medium 3. Now medium 1, let me take this as air, rarer medium, optically rare medium. Medium 2, let me consider as water, denser medium. So if it is air and water, air is rarer medium, water is what medium? Denser medium. And this is glass. If I take medium 3 is glass and medium 2 already as water, then you know that water, between water and glass, water is a what medium? Rarer medium with respect to what? Glass. So this is the simple case, like if you take water in a thick glass container, then definitely what happened? The refraction of light takes place in such a manner so that we know that light bend from one medium to another medium, and finally the light emerges out from the other medium. So if you look at this diagram, so today I just want to brief this diagram only. When light enters from air to water, so you know what happened? Light bends towards the normal. But the same light, when it goes from water to glass, again what happened? The light bends away from the normal. So this is the case where the bending of light takes place from one medium to another medium, that is from rarer to denser medium and from denser to rarer medium. So the expression part and the relation part I continue in the next class. Thank you.
Hello everybody. Welcome to yet another episode of the online accountancy class. We will be continuing with admission of a partner chapter. This is the third chapter given in the book, and the topics that are to be covered in this chapter: First is ratio analysis. Now, this is the first part of the chapter, and whichever question in partnership admission is done, ratio is the first step. So we have to calculate two ratios. One is the new ratio of all the three partners, and the other one is the sacrificing ratio. We'll be doing this in detail today. The next part is the accounting treatment of goodwill. How to value goodwill was done in the last class. Today, how it is treated in the books of accounts, the journal entries regarding various situations will be taught to you. The next part of this chapter is the revaluation of assets and liabilities. Then you have reserves and accumulated profits and losses. And finally, you have adjustments of capital. So today, we'll be covering up with the first 2 points, which is the ratio and accounting treatment of goodwill. Okay, now, what is ratio? Now, at the time when a partner comes into a firm, there are two partners already. The third partner comes into the firm. When the third partner comes into the firm, he will take some part of his share from the old partners. And then all the three partners will get something out of the profits. So this proportion in which they are supposed to get profits is termed as ratio. Now, in the ratio, we have two concepts which needs to be covered. First is the new profit sharing ratio. Now, this is the ratio in which all the partners, that is, including the new partner, will share future profit and losses of the firm. Now, any partner is coming into the firm with an aim of earning profit. So, the profit has to be given to the new partner. Now, who is going to give the profits to the new partner? The existing partners. For example, A and B. They were already in the firm. C enters a firm. So, A and B, out of their shares, will sacrifice something and give it to C. So, whatever C gets will be his share. And the second part, that is the sacrificing ratio, in whatever proportion the old partners have shared or have given out of their profits to the new partner is termed as sacrificing ratio. Now, sacrificing ratio is the ratio in which the old partners sacrifice their share of profits in favor of the new partner. So these are the two concepts. Whenever we start a chapter on admission, whenever we start a question, we have to first calculate the new profit sharing ratio and then the sacrificing ratio. Okay, now there are ways and means in how we calculate the new ratio. So there are basically three methods. We will be taking up each method followed by an example so that we understand the question and the concept well. So when a new partner may get his share from the old partners in their old profit sharing ratio. This is the first concept, and the question related to this is, see, the case 1 says when new partner gets his share from old partners in their old profit sharing ratio. So the question says Geeta and Babita. So Geeta and Babita, they are partners sharing profits in the ratio 5:3. That means Geeta gets 5/8, Babita gets 5/8. These are the old partners. Now Chetan is admitted for 1/4 share in the profit. So Chetan, he is the new partner. So he comes for 1/4 share in the profits. Calculate the new profit sharing ratio of the partners. So how do we go about with the question? There is nothing else given in the question besides the old ratio and the new partner's share. How do we go about it? So we take the whole profit to be 1. 1 minus 1/4. This is, we are subtracting the new partner share out of the total profit. We are left out with 3/4. So this 3/4 will be shared amongst Geeta and Babita in the ratio 5:3. How do we calculate this? So G's new share will be 3/4 into 5/8. And Babita's new share will be 3/4 into 3 by 8. So if you calculate this, it comes out to be 15 by 32 is to 9 by 32. And how much is Chetan getting? Chetan gets 1 by 4. So in order to make the denominators equal, we have to multiply 4 by 8 to get 32. So we multiply the numerator and the denominator. So the answer will be 15 is to 9 is to 4. So this is how we calculate the new partner's share. This was the first case when the new partner gets his share from the old partners in their old profit sharing ratio, because there was nothing else given in the question besides that Chetan gets 1/4 of the total share. So this was the first concept. Let us see the next one. The second one says the new partner gets his share from the old partners in a particular ratio. Now that ratio has already been mentioned in the question. So if the ratio is mentioned in the question, we will have to distribute the profits in that given ratio. How do we go about it? Just see, Sushil and Vishal are partners. So Sushil and Vishal are partners, sharing profits in the ratio 5 is to 3. So these are the old partners. Chanda is admitted for 1/5 share in the profits. Chanda comes for 1/5 share. So she comes for 1/5 share, which she gets 1/10 from Sushil and 1/10 from Vishal. Now from is given, that means straight away you deduct from the old partner's share. So 5 by 8 was Sushil's share. He is going to sacrifice 1 by 10 from his share. And Vishal also gives 1 by 10 from his share. So we are left out with, let us take the LCM, it comes out to be 40. 8 5s are, so 25 minus 4. This will give you 21 by 40. So this is Sushil's new share. What about Vishal? If we calculate this, we get 40 again. 4 3s are 12 minus 4 will give you 8 by 40. So this is how we calculate this is 15. 15 minus 4 will give you 1 by 40. 11 by 40. So Sushil's new share is 21 by 40. Vishal's new share is 11 by 40. And what about Chanda? Chanda got 1/10 from Sushil and 1/10 from Vishal. That means the total share that Chanda got was 2 by 10. Now, the new ratio is 21 is to 11. 21 by 40 is to 11 by 40 is to 2 by 10. So again, we make this as 40. In order to make it to 40, we have to multiply the numerator as well as the denominator by 4. So the new ratio will be 21 is to 11 is to 8. So this is the new ratio of the partners. Because it is straight away given that Chanda gets 1/10 from Sushil, so 1/10 will be deducted from Sushil's old share to make Sushil's new share come up, and Vishal gives 1/10 from his share, that is 3 by 8 minus 1 by 10, because 3 by 8 was the old share of Vishal. 3 by 8 minus 1 by 10, that makes it to 11 by 40, and Chanda will get 1/10 from Sushil, 1/10 from Vishal. That means it comes out to be 2 by 10. Now we have to make the numerators equivalent. So 21 by 40 is to 11 by 40. This also has to be 40. So we multiply this into 4. If we multiply the denominator by 4, we have to multiply the numerator by 4. So we get the answer as 21 is to 11 is to 8. So this was the second concept, how to calculate the new ratio of the partners when a particular ratio is already given in the question. Let's move ahead with the third topic. Now in this case, new partner gets his salary, his share by surrender of a particular fraction of their shares by old partners. Now here we'll have to take up one extra step. one extra step because the ratio has not been given to you directly. They say some portion of the old partner's share is given to the new partner. What does the question say? Homi and Vikram are partners sharing profits in the ratio 5:3. So Homi is to Vikram, the ratio is 5:3. Homi surrenders 1/20th of his share. So its surrender will be how much? We need to calculate this first. 5/8 into 1/20. We need to calculate this first. How much of his share is he surrendering? 1/20th of his share. So this comes out to be 5/160. 5/160. We can also take, let's see how much is Homi's new share in this case. 5/8 minus 5/160, because 5/160 he is giving away to the new partner, who is, who's the new partner here? Vishal. So he's giving it to Vishal. So 5/8 minus 5/160, this will be Homi's new share. So let us see how much it comes out to be. 160 will be the LCM. 8 2s are 20, 25s are 100, minus 5, this will give you 95/160. So this is Homi's new share. Let's talk about the other partner. Vikram surrenders 1/24th of his share in favor of Vishal. So Vikram's surrender is how much? Let us calculate. 3/8 into 1/24. This is what he surrenders. So how much is he left with? 3 8s are 24. This is 1/64. He surrenders 1/64 out of his share. So what is his new share? 3/8 minus 1/64. If you calculate this, we get Vikram's new share. Let us see what this comes out to be. The LCM will be 64. 8 8s are 64. 8 3s are 24. Minus 1. So this comes out to be 23/64. So this is the new share of Homi. This is the new share of Vikram. Now how much does the new partner get? Vishal. He's the new partner. So how much does he get? He gets 5/1/60 from Homi and 1/64 from Vikram. So let us see what the total comes out to be. 5/1/60 plus 1/64. We can further reduce this in order to make our question a little simple. 5 1s are 5. 5 3s are 15. 5 2s are 10. So this could be 1/32 upon 1/64. So when we calculate this, we are left with 64. So this comes out to be 2 plus 1. So 3/64 is Vishal's new share. So what is the ratio in which the answer comes out to be? The new ratio is 95/160. I'll write it over here. 95/160 is to 23/64 is to 3/64. Now this also can be cancelled. Let us see how we can cancel this. So 5 1s are 5, 5 9s are 45, 5 3s are 15 and 5 2s are 10. So this comes out to be 19/32 is to 23/64 is to 3/64. This is the new ratio. Now this can be made equivalent by multiplying this by 2. So this comes out to be 38 is to 23 is to 3. So this is the new ratio of the partners. So this is how we calculate, because first of all the surrender has to be seen. How much has he surrendered? So in order to calculate that, you have to multiply the proportion that he is surrendering from the old partner's share. So this was how we calculate the new ratios of all the partners. Let us move ahead. with the sacrificing ratio. Now, first of all, let us understand what is a sacrificing ratio. Sacrifice means he has given, the old partner has given something out of his share to the new partner. The old partner has given something out of his share to the new partner. It means that he has sacrificed something from his share. And in order to calculate the sacrificing ratio, there is a formula and it says old ratio minus new ratio. So when we calculate this, we get the sacrificing ratio. Now, let us take up case 1. When share of a new partner is given without details of sacrifice made by the existing partners. A simple question, Ratan is to Mukesh. They are sharing profits in the ratio 3:1. Nothing else has been mentioned regarding the ratio. It says, Anil is admitted as a partner for 1/8 share of profit. Anil comes for 1/8 share in the profit. And that is all that has been given in the question. You have to calculate the sacrificing ratio and the new ratio. Let's go ahead with this. So, first of all, we'll calculate the new ratio. So, how do we go about? 1 minus 1/8. So, this is the remaining ratio which is you are left with. This will be distributed amongst R and M in the ratio 3:1. That is 3/4 and 1/4. So, R's new share will be 7/8 into 3/4 and 7/8 into 1/4 will be M's new share. Now, when we calculate this, this comes out to be 21/32 is to 7/32 is to 1/8. So, 1/8 we have to make this to 32. So, to make it to 32 we have to multiply the numerator and the denominator by 4. So, this will come out to be 21 is to 7 is to 4. So, this is the new ratio. We did this when we were studying about the first case in the new ratio. Now, how do we calculate the sacrificing ratio? Now, in this case, where only this much is given, that this was the old ratio and the new partner comes for 1/8 share, even if we don't calculate, we get the answer because whatever sacrifice has been made by the old partners is in their old ratio. Hence, over here, the sacrificing ratio will be 3:1. How do we know that? The leftover profits are taken over by R and M in the proportion 3:1. So, the sacrificing ratio will be 3:1. There is one more method to calculate, that is old ratio minus new ratio. So, we can do it that way. So, the old ratio is 3/4 and the new ratio comes out to be 21/32. If we calculate this and for the new second part, 1/4 minus 7/32, if we calculate this, we will come out with an answer which is equivalent to 3:1. So, the sacrificing ratio in this case will be 3:1. So, this is how we have to go ahead with the question. Let us take up the second case. The second case says, when the old ratio of the existing partners and the new ratio of all the partners are given in the question. So, what does the formula say in order to calculate the sacrificing ratio? The old ratio minus new ratio will give you the sacrifice. And here in this question, they have given both old ratio as well as the new ratio. So, the old ratio for Manish and Rohit is given as 3:2. That means 3/5 and 2/5. This is the old ratio and the new ratio is given as 5:3:2. This is the new ratio. So 5:3:2 comes out to be 5/10, 3/10 and 2/10. Now it is very obvious that the old partners only sacrifice. The new partner doesn't sacrifice because he's coming into the business and he will earn or he will gain. That is why he's not sacrificing. So let us see what is the sacrificing ratio. The formula is old ratio minus new ratio. So 3/5 minus 5/10 and 2/5 minus 3/10. The second partner gets 3/10. So let us calculate this. If we calculate, this comes out to be 10. 6 minus 5. So this comes as 1/10. And here 10 again is the LCM. 4 minus 3. So this comes out by 10. So the sacrificing ratio is 1:1. So this is how we calculate the sacrificing ratio. Now, let us move with the third concept of calculations of the sacrificing ratio. When the old ratio of the existing, that is the old partners, is given along with sacrifice made by each partner. So it is a little different. Let us see how we go about with such questions. Okay. Priya and Kajal are partners sharing profits in the ratio 7:5. Priya and Kajal share profits in the ratio 7:5. This is 7/12, 5/12. How did we get 12? That is 7 plus 5 makes it to 12. They admit Alia as new partner who acquires 1/12 from Priya and 1/6 from Kajal as her share. So Alia acquires 1/12 from Priya and 1/6 from Kajal. This is what the question says. Calculate new profit sharing ratio and the sacrificing ratio. So how do we go about with this question? So Priya's sacrifice is 1/12. So 7/12 minus 1/12 will make it to 6/12. So this is Priya's new share. About Kajal, she sacrifices 1/6 from Kajal. So 5/12 minus 1/6. If we calculate, we are left out with 12. 5 minus 2. This makes it to 3/12. So this is Kajal's new share. And what about Alia? Her share will be, Alia's share will be whatever Priya and Kajal have sacrificed, which is 1/12 plus 1/6. If we calculate this, we are left out with 1 plus 2, which makes it to 3/12. Therefore, the new ratio is 6:3:3 or 2:1:1. So this will be the new ratio. Now, what about the sacrificing ratio? The sacrificing ratio can be calculated as 1/12:1/6, because 1/12 they took from Priya and 1/6 Alia took from Kajal. So how do we calculate this? 1/12:1/6. If we do it, we get it 2:1. So the sacrificing ratio here is 2:1. So this is how we calculate the sacrificing ratio. This is very, very important because this is the first step of solving the question. If the new ratio or the sacrificing ratio goes wrong, the complete question will be wrong, because we have to calculate various other particulars according to the sacrificing ratio or according to the new ratio. So we have to understand this very well. There are a few questions given in your text. If you solve those, I'm sure this would be absolutely clear. Let's move ahead with the next part of today's explanation. That is, how do we treat goodwill? What is the accounting treatment for goodwill in the books of accounts? Okay, now how is goodwill treated? Now, goodwill, we have done it last time. It is an intangible asset. And the new partner has to bring in his share of goodwill and give it to the old partners, because anyways he'll be taking the benefit of the goodwill of the firm and he'll be sharing profits. So it is his duty to give some part of the goodwill, which is his share of goodwill, to the old partners, and that goodwill will be shared amongst the old partners in their sacrificing ratio. So these are the various methods in which goodwill is brought by the new partner. First is when goodwill is paid privately. Now when something is not accounted, when something is paid outside the business, there is no journal entry in the question. So whenever in the question it is said that goodwill is paid privately by the new partner to the old partners, there won't be any journal entry in the question. The second method says premium for goodwill is brought in cash or check and is retained in the business. Third is premium for goodwill is bought in kind. Kind means besides cash, they might bring in asset or they might bring in stock, any of those. Fourth category says premium for goodwill is bought by a new partner and is withdrawn by the old partners either fully or partly. We'll be doing all these, how to go about with the transactions, in the coming slides. New partner cannot bring his share of premium in cash. Now there are situations when the new partner is unable to bring his share of goodwill in cash. So when he cannot bring in his share of goodwill in cash, his current account needs to be debited. That means he has to pay, whether be it from the cash that he has bought, or in case he cannot bring in cash, it is paid from his current account. Then new partner brings part of premium in cash or check. Supposingly a new partner coming in had to bring 30,000 and he could only bring 20,000. So 20,000 will be calculated in terms of cash and 10,000 will be taken up in terms of his current account being debited. Then the next concept is the hidden goodwill, and then goodwill appears in the old balance sheet. When we talk about old balance sheet, we are talking about the question. If there is goodwill in the question, first of all that goodwill needs to be written off. How are we going to do it? I'll tell you in the coming slides. Next is goodwill appears in the balance sheet and new partner is unable to bring his share of goodwill in cash. If the goodwill is there in the balance sheet, first of all we write off the old goodwill, and then if the new partner is not able to bring his share of goodwill in cash, the new partner's current account is debited because he has to pay whatever be it. If he cannot pay it in cash, his current account will be debited in the books of accounts. So let us take up each step line by line so that we understand the treatment of goodwill. Okay, so when premium bought in cash and is retained in the business, first it will not be considered because he paid it privately. So whenever there is a payment which is done privately, is not entered in the books of account. The second concept is when premium is bought in cash and is retained in the business. Now the new partner bought his share of goodwill in cash and that share of goodwill will be in the business. So the first journal entry goes as cash account debit to premium for goodwill. The new partner is bringing in cash and that cash is against the premium. So cash account will be bought in, so cash account is debited and to premium for goodwill will be credited. Now this premium will be distributed amongst the old partners in their sacrificing ratio. Now the entry goes as premium for goodwill account debited to sacrificing partners capital account or current account. Now there are two situations, either capital or current. So in case the capitals are fixed, we do the entries through the current account. If the capitals are fluctuating, we do the entries through capital account. So the goodwill bought in by the new partner will be distributed amongst the old partners in their sacrificing ratio. So these are the two entries. The next concept says premium for goodwill is bought in kind. Now cash is not bought in by the new partner. He could not bring his share of goodwill in cash. So what is done? Supposingly he has bought assets. So instead of bringing cash, cash account was debited in the last slide. Over here, asset account will be debited because the new partner has not bought cash. The new partner has bought assets. So asset account debited to incoming partner's capital account to premium for goodwill. Now the new partner brings in his share of capital also. Supposingly he bought maybe 10,000. So 10,000 will go to his partner's capital account, and whatever is the balance, his share of premium he could not bring in cash, he bought it through assets. So that will go to the premium for goodwill account. And the premium will be distributed amongst the old partners in their sacrificing ratio. Now this is a common entry for all the slides because whatever is bought in by the new partner is distributed amongst the old partners in their sacrificing ratio. If only one partner has sacrificed, in that case, only one partner gets the complete amount of goodwill. Let us see the next slide. It says, premium for goodwill brought by a new partner and is withdrawn by old partners either fully or partly. Now, cash bought in, similar entry, cash account to premium for goodwill. Distribution of premium, similar entry, premium for goodwill account debit to sacrificing partners, capital account or current account. Now here we see there is an additional entry. Why? Because the partners did not leave that cash in the business, they have withdrawn the money from the business. So when they withdraw the money from the business, cash moves out of the business, hence it is credited. So sacrificing partners capital account debited to cash account because they are withdrawing the amount from the business. There the cash goes out of the business, hence cash is credited. So these are the three entries in such situation. Next is when partner cannot bring his share of goodwill in cash and adjustments are made through his current account. Now he could not bring his share of goodwill in cash, so the first transaction will not come into picture because he could not bring his share of goodwill in cash. So, but the old partners will not compromise, they want their share. So instead of cash, the incoming partner's current account will be debited. So partner's current account debited to sacrificing partner's capital or current account. This is the next transaction. The next situation is new partner brings part of goodwill in cash. Now he was supposed to bring 50,000, he could only bring 20,000. So when he bought 20,000, 20,000 will be written here. Cash account debit to premium for goodwill because he only bought 20,000. So 20,000 goes there and the remaining 30,000 because he had to bring a total of 50,000. So the remaining 30,000 goes to his current account. So incoming partners current account debited, premium for goodwill account debited to sacrificing partners capital or current account. Whatever is the amount will be distributed amongst the old partners in their sacrificing ratio. So this was it. The next situation is hidden goodwill. Now for hidden goodwill, this is very, very interesting and it comes in the exams. It has come in previous years. Let us see how we calculate it. I'll explain it to you through an example. Supposingly A and B are partners with capital contribution of 1 lakh and 50,000, let's assume. 1 lakh and 50,000. C comes into the business bringing in for 1/3 share, he brings in 1 lakh rupees. So this is C's capital contribution and his share of profit is 1/3. So the first step goes like this. Calculate the net worth of the business on the basis of new partner's capital. So what is the new partner's capital? 1 lakh. So on the basis of new partner's capital, net worth of the business will be, if 1/3 is equal to 1 lakh, therefore 1 will be equal to 1 lakh into 3. So this would be 3 lakhs. So the net worth of the business on the basis of new partners capital is 3 lakh. Now calculate net worth of the firm by adding adjusted capital of old partners and capital of the new partner. Now let us see what are the capitals of the old partners. A's capital was 1 lakh, B's capital was 50,000 and C's capital was 1 lakh. So the total comes out to be 2,50,000. This was the first step. This is the second step. Now how do we calculate goodwill? Goodwill will be calculated as first step minus the second step. So 3 lakh minus 2,50,000, this would give you 50,000, and this is the value of your goodwill. This is the value of goodwill. This is how we calculate hidden goodwill. So the next concept is goodwill appears in the old balance sheet and new partner brings premium in full or part. So now I told you if it is in the old balance sheet, it means that it is in the question. Goodwill is given to you in the question. So if the goodwill is given to you in the question, that means it does not belong to the new partner. So the new partner does not have a say on the items which are given in the balance sheet. So goodwill is very much there in the balance sheet. Goodwill is given in the balance sheet. So if it is there in the balance sheet, it has to be written off against the old partner's capital. So the entry will be, let's assume there were two partners, A and B. So A's capital account debited, B's capital account debited to goodwill. So this will be written off. This is the entry for writing off goodwill. Goodwill will be written off from the old partner's capital account against the old partner's capital account in their old ratio. So this was the first entry, old partner's capital account or current account to goodwill. Now the concept of old goodwill is clear because it is finished. Let us see, the new partner bought his share of premium in cash. So cash account debit to premium for goodwill, the same entry. And then that premium is distributed amongst the old partners in their sacrificing ratio. So premium for goodwill to sacrificing partners capital account. This is when he brings in his full amount of goodwill in cash. But there are situations when he cannot bring his share of goodwill in cash, complete amount. So some part is taken away from his current account. So his current account is debited, new partners current account debited to sacrificing partners capital account. So this is how we go with the goodwill thing. So this was all about today's session. I'm sure you've understood, and please keep solving questions. We will do topics related to revaluation and capital accounts and capital adjustments in the next class. See you then. Bye.
Hello children, and welcome to ISC Sociology online video lectures. In our previous class, we learnt about the various kinship usages. And like I had explained to you, maybe some of you found the behavior and the attitudes followed by some of these groups very unusual. But at the same time, you might have also enjoyed how varied, how interesting these several groups are. Today, we will begin with the range of kinship, but before that, let me just quickly discuss some of the ISC questions which are based on the kinship usages. These are some of the common ISC questions. They are long and objective questions as well. Like for example, the first one, make a comparative study of the joking relationship and avoidance. In my lecture also, I have explained to you, normally we get long questions on avoidance, joking relationship, and covade. Amitate and avunculate usually comes for comparison in the objective section, whereas technonymy usually comes as a definition for only 2 marks. Sometimes you might get the comparison of both the usages. Like if it is for 5 marks, then 2.5 marks will be allotted for joking relationship and 2.5 marks will be allotted for avoidance. Sometimes you might only get avoidance for 5 marks, for which you will have to write at least 6 to 7 points. And while doing so, please do not forget to discuss the interpretations regarding avoidance given by the various anthropologists. Next is discuss the kinship usage of curvade. Here also I have explained previously how you can write about what is curvade, which tribe practices it, how it is practiced, how this behavior is practiced, and the reasons behind why this was practiced by those tribal societies. Technonymy just comes for 2 marks. Differentiate between avunculate and amitted again comes in the objective section for 2 marks. What do you understand by kinship usages? Over the years, when kinship usages were coming in the objective section, normally you had to give a definition or the differentiation. But in 1 year, there was a question, what do you mean by kinship usages? And most of the children were pretty confused with this particular question. Kinship usage, I have explained this before also, it is nothing but the behaviors and attitudes which are followed by the members of a group. And these attitudes we have already seen are very different from one another. And there are 6 attitudes or behaviors that we need to discuss in our syllabus. Next is what are curvade, amitted, avunculate, and avoidance known as? So look at question number 5 and question number 6. The same content, the same answer has to be written, but we have 2 questions here. And the same questions came back to back. For example, if you are writing about kinship usages, all these terms which are mentioned here, like curvade, amitted, avunculate, and avoidance, are nothing but examples of kinship usages. So your answer for question number 6 would have been, these terms mentioned are the examples of kinship usages. So in this way, the pattern of question might change. Please do not expect direct questions every time. So you have to be ready with the changes that are coming in the question pattern. Next, we come to range of kinship. Now, what do you mean by range of kinship? The meaning is it refers to the number of individuals who form a kin group. What is a kin group? That I have already explained in my first lecture. I have also given you the explanation of the spider and the web that it spins. And I have also told you people to imagine yourself as a spider who is in the middle of the web of social relationships. We all belong to a kin group. We all are members of a particular kin group. But a kin group could be big or small, meaning the size of the kin group could vary. Depending on the size of the kin group, or depending on the number of members who form a kin group, we have 2 range of kinship. One is the narrow range and the other one is the broad range. Now in the textbook also it is written, because I remember 1 year there was a question on what do you mean by range of kinship? Instead of asking, right, name the 2 range of kinship or give examples of narrow range or give examples of broad range, that year the council decided to twist the question a little bit and ask, what do you mean by range of kinship? So here, range of kinship, as explained in the book, is it is a network of kinship. You're related to somebody through marriage, you're related to somebody through blood, you happen to be a member of a particular tribe, you belong to a particular clan. For the Hindus, you belong to a particular gotra. These will be your network group. So the network of kinship can be developed depending on number of persons, meaning how many individuals are there in your kin group. And depending on the number of individuals, like I was explaining before, you could have a very big family, you could have a very small family, you could be a member of a very, very big tribe, you could be a member of a very small clan. Then in that particular case, we have two range of kinship. One is the broad range and the other one is the narrow range. And with terms like broad and narrow, you might have already figured out the size of the group. So let us now go into the broad range kinship. Broad range kinship, the examples are given here, are tribes and clans, all right? So here I have given the explanation of broad range kinship. In this broad range kinship, we have more individuals. So just imagine any tribe. Like if I give you the example of Naga tribe, right? The Nagas who are from Nagaland. There are many clans of the Nagas. You might have the Aos, the Angamis, the Semas, the Rengmas. There are many clans. The tribe is divided into many clans. But if you're going to count all the members of that particular tribe, then you could have it in a large number. So we claim this kin group. We claim all the Nagas as belonging to the broad range of kinship. Broad meaning very, very big. Because we are not only counting these tribes who are from Nagaland. You might be in any part of the world. You might have settled in any part of the world. But as long as you share that kin membership, then you will come under the broad range kin group. Then, in the same way, we could also have here a clan. Like I was giving the example of the Naga tribe who are divided into several clans. And I will take the example of a simple, very, very simple clan, which is the Angamis. You might have a lot of Angami Nagas. They could also, the population could go up to lakhs, more than lakhs also. In that particular case, you cannot club them under a narrow range. Since you have more members, it has to fall under the broad range. So if I have to give an example of this particular region, a very, very popular tribe here, which is the Lepchas. The Lepcha tribe also, so many Lepchas are there, so you will come under the broad range. And the Lepchas are also divided into various clans, like you can have the Molamo, the Yongmo, the Sadamo. All these are clans. So if you just count the numbers, the clans and the tribe group will fall under the broad range. Now coming to the opposite of that will be the narrow range. And narrow range meaning, it's very, very simple. Narrow range here meaning we have less number of individuals. By less, I do not mean just one or two. Less meaning here, individuals who form a group, relationship is very close and informal, and less kinship terms are used. And if I can just give you the example of narrow range, we have nuclear and extended family. So think about your own family. Today, most of you live in a nuclear family where you just have 3 members or 4 members. So if tomorrow somebody will ask the range of your kin group, if you belong to a nuclear family, then you will say, yes, I belong to a narrow range kin group because I just have 4 members. And in a group of 4 people, they have a very close relationship. And also, less kinship terms are used. Mother, father, brother, and sister. Right? That's it. But when you are talking about your identity as a particular tribe or a member of a clan, yes, you can belong to a broad range and a narrow range at the same time. Extended families. Now, today we mostly come across either nuclear families or extended families. and they're very less in number. Sometimes even if the whole family comes together, it will not be more than 30 to 35 members. So 30 to 35 individuals cannot be grouped under broad range. We will put them under the heading of a narrow range kin group, where the kind of bonding amongst the individuals are very, very close. But amongst the broad range kin group, more terms are used, as well as the relationship could be very, very informal as well. Now, after I have done the range of kinship, now let me just discuss the ISC questions for range of kinship. Normally you get objectives like, what do you mean by the range of kinship? And I've already explained, range of kinship refers to the network where we count the number of individuals or number of members in a kin group. Next, give 2 examples. Now, these are very easy questions. 2 examples of broad range and narrow range. So, broad range, I had given you in the slide itself, will be tribe and clan. Very easy to remember. When it comes to narrow range, just write down nuclear family and extended family. The next one is discuss. Now, this will come in the long answer section for 5 marks. Discuss the range of kinship. So they have not specified, right, either of the kin group. You have to write both. So begin your answer. Since you have to give it in paragraphs, begin your answer by defining range of kinship. Please mention the 2 types of range of kinship. And in 2 paragraphs, you can explain what is broad range and what is narrow range. And in 2 or 3 lines, you can just conclude your answer. This way, it will be easy for the examiner to correct your answers. Next is differentiate. It is the same thing. Discuss is the same thing, but in differentiation, I would recommend all my children to please make a table, a tabular form while studying also and while also writing your answers. So in a tabular form, if you can just compare the 2 range of kinship, then remembering, memorizing, right, would be easier. Retention, that power will also increase. At the same time, your answer writing will also become very good. Now we move on to the kinship terms. Now, kinship terms are those nomenclatures used to refer individuals of a kin group, and we have 2 kinds of terms. One is classificatory and one is descriptive. So what have we all learned? We have learned the types of kinship. We have learned degrees of kinship. We have learned kinship usages. We have learned range of kinship. And now we come to the kinship terms. How do we call our mother? You either use, all right? Some of you call mummy or ma or ama or mama. These are the terms that you use to call your mother. You do not address your mother by calling out her name. So you have so many individuals in your family, and for each of them you have a particular term. Like, even though if that person is not related to you, we still use those terms. Just imagine a situation that you're going out to the market and maybe to purchase some few vegetables. So if you see an old lady, the first thing that comes out of your mouth is maybe you address the lady as a grandmother or boju or dadi, then that looking at the age group. Or if you want to hire a taxi and you see a driver over there, if that driver is a middle-aged driver, the first thing you refer to that person is bhaiya, all right, or a brother, because that person is not related to you, but you are using that particular term. So in our day-to-day lives, we have terms which we use to call our close relatives, and we also have terms to address people who are not related to us. Now, there is a difference between the Indian system or the Eastern system of calling out our individuals and the Western system where they address or where they call out the individuals. If in, let's say, America, a child who goes to a supermarket and then he is being helped by an assistant over there, I do not think he would call that particular, if there's a lady, he wouldn't call that lady by addressing her as sister or aunt or grandmother like that. If he sees the nameplate, all right, and it's written Jane, so straight away he would say, Jane, I would want to purchase a few toys. Instead of using the term, he would use the name. So there is a difference between the system of addressing in the Indian society and in the Western society. Now, talking about these terms, it's there up in the slide here as well. There are two types of terms. One is classificatory and descriptive. Now, in most of your textbooks, the explanation will start from descriptive and it will go to classificatory. But I think we have to study about the evolution of these terms as well. So I will discuss the classificatory first and then I will go to the descriptive terms. Now, classificatory term. What is the meaning of classificatory term? If one kinship term, please look at this very carefully, if one kinship term is used to refer, look at the difference here, only one term, but it is referring to what? Many individuals. One term, many individuals. Often, now when I am talking about many individuals, what do I mean by many individuals? Many individuals meaning it could be individuals belonging to different generations in the sense grandfather, uncle, brother, great-grandfather, they all belong to different generations. This system, all right, of using one term to address many individuals is known as classificatory term. Now, example, look at this term, uncle. Now, uncle is just one term. Uncle is an English classificatory term. So we are talking about this English language. Uncle here, it could refer to, for example, if I just make up a sentence, my uncle will be arriving from London. Plain and simple, you have an image in mind of a male who is coming from London. But which uncle am I referring to? That is not clear. It could be your father's brother. It could be your mother's brother. It could be your neighbor next door. It could be your mother's younger brother. It's not very clear, but you are going to use the same or you're going to use one term, that is uncle, to address many individuals. Another term like that is brother. Again, a very, very common term. Brother could mean, again, your own brother. It could also mean your aunt's son. It could mean your uncle's son. It could also mean your neighbor next door. It could also mean somebody from your school, brother. But that clarity is not there regarding the relationship between the individuals. So these are terms where we address people not only of, all right, the same of different generations, but also we are addressing people who are related to us and who are also not related to us. Now, what could be the reason of this? There is a history of using classificatory. And for this, I would like to read out few things which is written by Lewis Henry Morgan, the person who actually came with these kinship terms. Now, the scientific study of kinship began with the publication of Morgan meaning Lewis Henry Morgan's System, this is the name of the book, Systems of Consanguinity and Affinity of the Human Family, and it was published long back in 1870. So Lewis Henry Morgan, he had already visited various groups, he had been among various tribes, he had researched, he had already written books, and then on kinship, the research on kinship was already there, and he had also written a book and published it by 1870. In the book, he mentions about a system called the Dakota type of nomenclature. You have it on the slide here, the Dakota type of nomenclature. Now, what is Dakota type of nomenclature? Morgan explained in the book that when he had gone to Dakota and he had spent quite a number of years researching about the tribal or the group over there, he came across the strange usage, all right, among the members of that group of addressing a close cousin, relative, by using just one term. So here, when he is mentioning the group, he says, Morgan gives the example that one's father, one's own brother was addressed by the same term. Now, father and brother belongs to two different generations. They might fall under one gender. Both are males. But they belong to two different generations, yet they were using the same term. This system later, he referred this system, this practice as Dakota type of nomenclature. Now, this is found, this Dakota type of nomenclature is found among the Inuits and Crow Indians, Nagas and Khasis. I have given, several tribal groups, both from India and outside India, all right? And the common ones in India would be the Nagas and the Khasis. And just to explain it in detail, I will just read out how it is practiced amongst the Nagas. Now we consider some examples of classificatory kinship system. The Sema Naga. Sema is a clan, Naga is a tribe. The Sema Nagas, they use the term Aja. So let's learn a little bit of Naga. They use the term Aja. Aja means, now just visualize, mother is referred to as Aja. Father's brother's wife, all right? Father's brother's wife, who is a female again, is referred to as Aja. Mother's sister is referred to as Aja. So if one term, Aja means mother also, mother's sister also, and your aunt also. Your mother's brother's wife is also called Aja. At the same time, they also use the word Angu, another Naga word, Angu. Angu meaning mother's brother, which is your mama, mother's brother's child, husband's father, wife's father, husband's brother, wife's brother. That means all the male, all right, relatives are referred to as Angu. And there is a big difference between wife's father, he belongs to another generation, and wife's brother belongs to another generation. But the father and the brother of the wife is referred to by one term, that is Angu. So if you just happen to shout out Angu, probably the wife's father will also look at you and the wife's brother will also look at you. So I feel I've explained in detail regarding the classificatory kinship term. Now, after looking at the details of the classificatory system, one question that should come to our mind is, why were they using one term? What were they lacking here? Couldn't they come up with several other terms? Now, this is very confusing. Like I said, if you just shout out Angu, you'll have so many people looking at you. So the reason could be lack of advancement in speech and vocabulary. You're talking about the tribal groups. Remember, the book was published in 1870, which means maybe the speech and vocabulary of those tribal groups had not developed. That is the reason why they were trying to make do with one term and refer it to several individuals. So later on, time passed by, and we did have some development in speech and language and vocabulary. So we come up with the descriptive term. The word itself will tell you describe. It means you have to give detail about everything. What is descriptive term? If an exact or direct term, no confusion. Angu, there is confusion. Is it the wife's brother or is it the wife's father? But when you are talking about descriptive term, no confusion. Absolutely clear that this is used to refer individuals of a kin group. For example, wife. A while ago, I just gave a sentence. My uncle is arriving from London. And then it was a little bit confusing, because until and unless you do not know which uncle, it is pretty confusing to find out which uncle you are referring to. But if you have the same sentence, and if I just replace uncle with my wife is arriving from London, you will not have any confusion, right? Then husband, in the same way, husband, or mother, or father. My mother baked a cake for me. My father gifted me a camera. There is no confusion regarding these terms because you're so exact, you're so direct, you're so precise with that particular term. Now, this shows the direct line of relationship. Angu was not showing direct line of relationship. Wife's brother or wife's father. 2 generations. Direct line is not there. But when it comes to wife or husband or son or daughter, there is a direct line of relationship. My son loves to play football, which means that there is no confusion. My son means not somebody else, it's your son. That line is very, very clear. Now, the reason, see, sometimes the line of succession is also given in Bengali language, like Borda, Major Di, Choto Bon is often used. Now, just to bring out or to compare the classificatory and the descriptive term, it will not be, I think I will not be justifying this explanation if I do not give the example of the descriptive term which is there in the Bengali language. Because in the Bengali language, it is very clear and it is very exact and it is very precise regarding how the individuals are addressed. Like, for example, in Bengali term, examples can be provided from Bengali kinship terms which are explicitly descriptive in the sense it pinpoints the exact relationship of a person and his or her kins. Father's elder brother. A while ago we used the term uncle. But uncle is not clear whether you're referring to father's elder brother, father's younger brother, mother's elder brother, mother's younger brother, the neighbor next door. It's not very clear. But in Bengali language, father's elder brother is called Jetha and younger brother is called Kaka. So if you say, my Kaka loves to eat fish, Kaka will always be father's younger brother. Then we have own elder sister is called Didi. The younger one is termed as Bon, like I have written here, right? But the line of succession meaning the position of individuals. Who was born first? You have 7 brothers, but who is the eldest? All right? That also is given so clearly. The eldest brother will always be known as Borda. Borda meaning the eldest. The middle one, all right? If it is a sister, the middle sister, she'll be known as Majodi or Majoda in case of a male. If you have a younger sister, she will be known as Choto Bon. So the line of succession is also very, very clear, which means these terms are known as descriptive terms. Now, found in modern societies, the more developed the languages, and it also shows the development of the society as well, all right? So, as and when language developed, the descriptive terms were also used. And then it shows here, all right, how good that particular group is in terms of language, in terms of speech, in terms of vocabulary. So first we had the classificatory system, and then later it developed into the descriptive one. In our own, all right, society, that is in Nepali society also, we do have a lot of these descriptive terms. If you just begin writing it, you will, I think it will cross more than 100 as well, right? But as students, since we have to stick to the syllabus and the textbook, I would recommend you, while you're writing answers on descriptive terms, please stick to the ones that are given, the examples that are given in your textbook. Again, let's discuss the ISC questions from these kinship terms. Give one example in the short question, one example of classificatory and one example of descriptive term. So just one that they have asked. So one would be in classificatory, it could be aunt. In descriptive, it could be mother. For the long question, differentiate between classificatory and descriptive. For that, whenever you see the word differentiate, please make sure you make a table to study also, to write also. And write down the number of points that you are comparing, all right? Last but not the least, discuss the types of kinship terms. Again, when you're writing kinship terms, introduce your answer by explaining what is kinship terms. Then you have to write that there are two kinship terms. First, start with the classificatory. Second, go with the descriptive. And not to forget, please give plenty of examples. Now, I will conclude today's lecture by telling you about descent. I will explain to you what exactly is descent. Descent is the origin of man. It is your history. And whenever we are trying to find out the descent of an individual, we cannot move ahead. We can't go forward. We always have to backtrack. We have to go backwards to find your origin, all right? Your origin in terms of birth, right? Your origin in terms of blood, and your origin in terms of residence, that I will do individually, I will explain individually, and also the social identity. The two types of descent, we have two types of descent. One is unilateral and the other one is bilateral. Unilateral can be divided, again, we have in unilateral examples are there. One is matrilineal and the other one is patrilineal. Now you cannot understand descent, though I have given you the meaning and definition of descent, is the origin of an individual. You get to know about a person's identity. You get to know about a person's history in terms of blood ties, in terms of the relationship, etc. But you will not be able to understand descent until and unless I explain to you the features of descent. Now let's look at the features of descent. Members of a descent group, all of us belong to a descent group. We all have an origin, all right? Members of a descent group, they identify themselves with a common ancestor. There has to be an origin. There has to be an ancestor from whom we have descended. So the ancestor could be, it has to be, it can't be, could be, it has to be a human being. I will come to that later. But there has to be a point of origin. That is what I'm trying to say. And the origin will be the ancestor. You could have a female ancestor, all right, who is called a cognate. A female ancestor is called a cognate. And you could have a male ancestor from whom you descended. Male ancestor is called agnate. So you have learned two new terms, agnate and cognate. Agnate meaning male ancestor, cognate meaning a female ancestor. Ancestors are not mythological or symbolic. Like we find many, like some might say, I have descended, we are the descendants of Ram, or we have descended from this or that. You cannot have, while we are talking about a descent group, we will not take into consideration the mythological ancestors. We will not also consider symbolic ancestors. If you later on study about totemism, then you will be very surprised to find out that there are some groups who believe that they have descended from fruits and flowers and trees and plants, etc. Now, from I think most of us, 100% we cannot come from any plant or fruit or flowers like that, right? Therefore, descent group does not take into consideration any mythological or symbolic ancestors. In a descent group, the ancestor is a human being. Human beings can only come from human beings. Next is the members are linked by blood naturally. The point of origin, if it is there, and if you have come, all right, then what we find is that every relative of that descent group is linked to each other through blood relation. You all are families. You all are relatives. Next, marriage is not allowed. It's impossible since you're related by blood, since they happen to be your relatives. It's a big no. Marriage is not allowed amongst the members of a descent group. Inheritance and succession. Who gets the property? That will be followed as per it's enjoyed by the members, that will be followed as per the rules that are there of the descent group. So features of the descent group I have explained. Now let me quickly show you. Now let me quickly compare the two descent groups, matrilineal and patrilineal. And after this, it will become quite clear to you what exactly is a descent group. Matrilineal, the clue is MA. MA means Ma. It has to be a mother. In this group, the mother is the head of the family, or the female is the head of the family. It could be a great-grandmother, it could be grandmother, it could be mother, depending on whoever is alive. The female is the head of the family. Property is passed from mother to daughter. Because the female is very influential and powerful in this society, property is usually inherited by the daughter. Again, there is a special daughter which is the youngest daughter. The youngest daughter in that group gets more share of property than the others. The next one is after marriage. They are matrilocal, which means after marriage, it is not the wife who moves out, but it is the husband who moves in along with the wife. The daughter of that house will not have to go out. Next, children will inherit the customs and traditions of the mother. In India, we have a lot of matriarchal tribes like Khasi and Garo. Right? These are some of the popular matriarchal tribes. Then patrilineal is just the opposite. Father is the head of the family. 99% of us belong to patrilineal families. Property is passed down from the father to the son, right? Son means especially the eldest son. After the father passes away, normally the eldest son takes all the responsibility, so he gets more share than the others. Even when it comes to marriage, it is patrilocal. After marriage, it is the wife who moves in to the husband's house. And the children will inherit not only the property, but the customs, the traditions, the surname of the father. Meaning, the male member is more powerful in this particular descent group. So I hope you have understood the kinship chapter. With this, we have ended and covered almost every topic in the kinship chapter. I hope you will benefit from this explanation. Thank you very much for watching my video. Until next, stay safe, stay indoors, and save lives.